Sine and Cosine in the Park with James, Jennifer, Derek, and Jordan. In this video, we'll demonstrate just how prevalent sine and cosine are in our society as shown through this park. And no, we're not talking about a sine in the park, we're talking about the trigonometric function called sine. I think Jennifer's found one.
Hey Derek, look, there's a sign.
Where?
Right there.
Oh, wow.
What's it? You see it?
Yeah.
Here, James shows us a piece of the playground. Not just any piece though, it's shaped like a sine function. The function sine oscillates between the central point called the reference line. In this case, the reference line is the middle bar in between the curves. The maximum distance of the curves from the middle is called the amplitude. Also, this structure represents sine because it begins at 0. Now Jennifer is pushing Derek on the swing sets. Although it may not look like it, this activity is actually also representative of sine and cosine. Through these swings, we can understand periods. As you can see, Jennifer reaches a certain height on both sides of the swing. This certain height is reached repeatedly, representing a repetition. The definition of a period is the time it takes for a function to start repeating itself, and in this case, it repeats itself every time she swings back and forth. The idea of a period can be found everywhere and anywhere in our daily lives. Here, Jordan stands on something commonly found in playgrounds. What we may have noticed about it before, however, is that it is a sine graph. When he flips it around, it turns into a negative sine graph.
In this clip, Derek bounces a basketball and then proceeds to throw it at James, which was like hella rude. Anyways, we will now represent this bounce as a cosine graph. First, we need to set up the graph. This is a rectangular graph with an x-axis labeled seconds, which represents time, and a y-axis labeled feet, representing the height at which the ball is bounced. Next, we have our equation. Negative cosine pi x plus 1. This represents the ball's movement after it has hit the ground and shows how high it bounces in a certain period of time. To find the period or when the graph repeats itself, we can use the nifty formula 2 pi over k. K in this case is pi. So when plugging the values in, we get that the period is 2, and since that it is on the y-axis, it is 2 seconds. Now, label your graph so that the function doesn't end up being too small or too enlarged. Then, find your reference line and your amplitude. In this case, they're both 1. Remember that the function oscillates around the reference line. It's the middle. Time to plot the points. The table shows the points that have been plotted. And then connect the dots and you're done. You have made a cosine function that represents the basketball's bounce. Keep in mind that this cosine graph only represents one bounce, and that in reality, the ball bounces lower and lower each time, so this can only represent the ball bouncing once, or if the ball just bounced continuously with the same height. For this example, we have a treadmill. Not a functionable one though. Those are for top of the hills. So pictures will have to do. Keep your eyes on the blue tape. Every single time that it moves along the belt of the treadmill and reaches the same spot again, it represents one cycle, or one period. The different speeds on the treadmill creates different periods. If the speed is at 1, the period is way longer, as it takes a large amount of time for the blue tape to reach a full cycle. As we ramp up the speed on this machine, the blue tape starts to cycle faster and faster, representing the change in period. As the tape cycles in less time, the period becomes shorter and shorter. So, next time, instead of asking how fast you run on the treadmill, you should ask how many periods you run per hour or something, or minute.
Now we have yet another example of a period. As James maneuvers the wheel to spin, keep your eye on the green tab. Every time it reaches its starting point again, it will have rotated once 360 degrees. This counts as one period.
But unlike the treadmill, this is a constant rate.
Throughout this video, we have shown a few of the many applications of sine and cosine in the real world. Maybe now you will be more wary of them yourself.